The last integral that we have to deal with in this problem is a very important integral because it relates this integral of a power times the exponential with the factorial. And actually this has more consequences that you may be able to study in calculus 2, right? Okay, for the time being we're going to focus on that, and the way we're going to deal with this is just to refer to this integral as in and try to derive a recursion for this, a recurrence. Okay, typically what you have to do to derive a recursion is to integrate by parts. And in this case it's very easy because we know a primitive of this is just minus the exponential, so we have this between 0 and infinity minus, with this minus is a plus, the exponential times the derivative of this, which is t and t, sorry, n t n minus 1. Alright, n is any natural number, so that means this exponent is at least 1, which means that for t equals 0, this is 0. And for t infinity is also 0 because of the exponential, so this is just 0. So what we have here is n times the integral from 0 to infinity t n minus 1 e minus t dt. And it turns out that this is just I n minus 1. So what we have here is I n is equal to n times I n minus 1. Well, it's clear that we can repeat this argument over and over. So that would be n minus 1, I n minus 2, n minus 1, n minus 2, I n minus 3, and so on. So what we have at the end is n minus 1, n minus 2, etc. to 1, I 0. Okay, you see? The factor you're multiplying here and the index are related. This is 1 unit more than this one. So once you get here to 1, what you have here is 0. And that is the n factorial times I0. So all we have to calculate for this integral is what is I0. I0 is this, which is a very easy integral to do because it's got a primitive. For t infinity, this is 0, so you have to subtract, with this minus is a plus, the value at 0, which is just 1. So I0 is 1, and then the result here is just n factorial as predicted.